This is Chapter 10, Lesson 7, Factoring Second Degree Polynomials. So we've done lots of equations like x squared plus 3x plus 2, where we have to factor it. Now we're going to do some more complicated equations. What if there's a coefficient in front of our x? What if we have an equation like 6x squared plus 17x plus 5? Well, this is the method for working this type of equation. First thing you have to do, if there's a coefficient in front of x, in front of the x squared, is to make sure that your equation is already in lowest terms, that you don't have any common factors between all of the terms of the equation. This has no common terms. 6, 17, and 5 have no common factor, so we're already ready to start using our method. What we're going to do is draw our grid, which you're familiar with, and draw our grid lines. Okay, we know that this top left box is going to have our 6x squared. We know that the bottom right box is going to have our 5. And we know that the other two boxes are going to add up to 17x. To figure out what goes in those other two boxes, what we're going to have to do is multiply the coefficient in front of our x squared by our 5. So we're going to take whatever number is in front of x squared and multiply it by our 5. So that means this number here multiplied by that number. 6 times 5 is 30. Now we have to write down all the factor pairs that we can use to make 30. We can make 30 with 1 times 30, or with 2 times 15, or with 3 times 10, or with 5 times 6. Now, to decide which factor pair we're going to use, we have to look at our signs. We have a positive sign in front of our 5. So that means that we have to multiply either a negative number times a negative number, or a positive number times a positive number. So now we look at the sign for our middle term. It's positive. Since our middle term is positive, that means we know that we have to have two positive terms. So we're going to find the pair of factors that will add to give us the coefficient in front of our middle term. So we want to find the pair of factors that adds to 17. 1 plus 30 is 31. 2 plus 15 is 17. That's the pair that we want to use. So we're going to use a 2 here and a 15 here. We would have been just fine putting them the other direction. And then we know these both have to have an x because we have to have something that adds up to 17x here. So we need a 2x and a 15x. Now we have to figure out what our factors are. For our first row, what is our greatest common factor? Well, if we look at the coefficients, we have a 6 and we have a 2. The greatest common factor between a 6 and a 2 is a 2. Now we look at our variables. We have an x squared and we have an x to the first power. Whenever you're dealing with variables, if every term has the variable, then your greatest common factor is going to be the lowest degree you have of that term. Our lowest degree is x, so this is going to be 2x. Now let's look at our second row. Look at our, we have 15 and we have 5. The greatest common factor between 15 and 5 is 5. We do not have an x term in this second box on the second column, so we won't have an x term here. We'll just have the 5. Now we'll look at our first column. We have 6x squared and we have 15x. So the greatest common factor of our coefficients, which are 6 and 15, is 3, because 3 times 2 is 6 and 3 times 5 is 15. Now our variables, we have x squared and we have x. So both of our terms have an x in them. Our lowest degree x is just an x. Now we look at our second column. We have a 2x and we have a 5. Our greatest common factor there is 1. So this means that we can factor this equation as 2x plus 5 times 3x plus 1. So the steps we take to work this kind of problem is that first we make sure that there are no that we do not have a common factor in all of the terms of our expression. Then we multiply the coefficient of x squared by our constant. And then we find all the factor pairs that multiply to make that constant. Then we look at our sign in front of our middle term and in front of our last term to determine whether we need the sum of the factor pairs to add to our middle term or whether we need the difference to be our middle term. And once we have that, we plug in our numbers. We find the greatest common factor for each row and for each column, and then we write them down. So let's work some of the problems. The first one we're going to look at is number 4. Okay, so for number 4, you are given an already worked out diagram of a problem. And it says to express the area of the figure both as a polynomial in simplest form and as the product of two binomials. Notice it asks for two different forms. Please do not just write 2x squared plus 17x plus 36. That's only half of what it asked for. It asked for this polynomial in simplest form, which is what this is, but it also asks for the answer as the product of two binomials. So you need to write the polynomial, and then you need to say that it equals 2x plus 9 times x plus 4. If you do not write both forms, then you have not finished the problem. So look at part C. We have an already finished equation here. We can write out the simplest form of the polynomial, which is 12x squared plus 7x minus 12. And that has to equal 3x plus 4, and I've run out of room, times 4x minus 3. Okay, so let me write that down here. 12x squared plus 7x minus 12 equals 3x plus 4 times 4x minus 3. So you need to write out the full answer. Don't just write out part of the answer. You need to write out the polynomial form that's inside of the grid, and you need to write the product of the factors. Write out both forms. I keep getting homework with only the polynomial written out. I also need this. So please make sure that you do both forms. Okay, this was number 4, which is just like number 9 that I assigned for homework. The next one we're going to look at is number 5. Number 5 is just find each of the following products. This is nothing that you haven't done before. I'm going to do just a couple of examples. Part A, we have 3x plus 1 times x plus 12. I'm going to work this one out just multiplying each term in the first parentheses by each term in the second parentheses. So I'm going to start by multiplying 3x by the second parentheses. 3x times x is 3x squared. 3x times 12 is 36x. Now I'm going to do my second term. 1 times x is just an x. 1 times 12 is 12. I combine like terms. I get 3x squared plus 37x plus 12. So that's the answer for 5A. Now I will do 5B. 3x minus 2 times x plus 12. This time I will use the grid method. So I'll draw my grid. And now we fill it in. We have 3x minus 2. We have x plus 12. X times 3x is 3x squared. X times negative 2 is negative 2x. 12 times 3x is 36x. 12 times a negative 2 is negative 24. So our final answer here is going to be 3x squared plus 34x minus 24. So that's what it would look like if we used the grid method. So next I will do one more problem from number 5. Part C is 3x plus 2 times x plus 6. So I'm going to use what is called the FOIL method, just so that you hear what that is. FOIL stands for first, outer, inner, last. So first means you multiply the first terms of each parentheses. Our first terms are 3x and x. 3x times x is 3x squared. Outer means you do the outer term in each parentheses. Well, the ones on the outside are 3x and 6. So 3x times 6 is 18x. Inner, those are the terms on the inside of the parentheses. So that's going to be our 2 and our x. So that is 2x. And then last, that's the last terms in each parentheses, 2 times 6, which is 12. We combine like terms. We get 3x squared plus 20x plus 12. So that's 3 different methods that you can use to work out the products. I don't care which method you use. Just be careful to make sure that you multiply all of your terms together. So that was number 5, which is just like number 10 that I assigned for homework. Okay, the next one we're going to look at is number 6. Number 6 is actually factoring. So let's look at a couple of these. For part A, we have 2x squared plus 15x plus 17. I'm sorry, plus 7, not 17. Let me get rid of that. Okay. So what we're going to do is draw our grid and put in our grid lines. Okay, we know that our top left box is going to be 2x squared and our bottom right box is going to be 7. What we have to do now is multiply the numbers in these two boxes together. 2 times 7 is 14. And now we write down all the factor pairs that can make 14. 1 times 14 or 2 times 7. Okay, our 7 is positive, and that means we can get that only by multiplying either 2 positive numbers or 2 negative numbers. Since our middle term is positive, that means we must have 2 positive numbers. We want to find which factor pair adds to 15. Well, 1 plus 14 is 15. So we're going to use 1 and 14. So we're going to have a 1 and a 14. And those have to be x's because they have to add to 15x, so they have to be x's. Now for each row in each column, we find the greatest common factor. In this first row, our greatest common factor is just an x. In our second row, the greatest common factor is a 7 because 7 times 2x is 14x and 7 times 1 is 7. In our first column, our greatest common factor is 2x because 2x times x is 2x squared and 2x times 7 is 14x. In our second column, our greatest common factor is 1 because 1 times x is 1x and 1 times 7 is 7. So to factor this out, we would write 2x plus 1 times x plus 7. Please write your answer in factored form. Don't just draw the grid. Okay, so now we're going to also look at part B, which is 2x squared plus 13x plus 7. So we're going to draw our grid again and put in our lines. And we know again that our top left box is 2x squared and our bottom right box is 7. We can use the same factor pair list that we already made. This time we end with a positive number, so we do know that it's going to be either 2 positive or 2 negative again. Our middle term is positive, so we know that it is going to be 2 positive numbers. We need to find the pair that adds to 13. Wait a second. Oh, okay, so I wrote the problem wrong. Let me fix that. Okay, so this last one, actually, instead of a positive 7, it's a negative 7. Okay, since it's a negative 7, that means we're going to have a positive term and a negative term. We need to find the pair of factors that has a difference of 13. That is, again, going to be 1 and 14. Since our answer here is positive, that means our 14 must be, our positive number must be the bigger one. Our negative number must be the smaller one. We get our greatest common factor in each row and column again. And we get x plus 7 times 2x minus 1.